Hi, my name is Dan Gerlowsk. I'm a professor of economics at the University of Baltimore. Today we're making a short review video to try and bring home some of the ideas in economics about demand elasticity. What we're supposed to learn in this segment, or what we're supposed to talk about at least, is what is price elasticity and what does it mean? How does it relate to human behavior? We want to find two ways to measure price elasticity of demand, and we will learn the point measure and the arc measure for elasticity of demand. And we also want to at least understand the concepts behind other elasticities affecting consumer demand. And in particular, we want to look at the cross-price elasticity and the income elasticity of demand. So that's our goal in this short video. I hope this video supplements your learning from traditional textbook and online sources for this material and does not replace it. We all know that demand curves slope down. We've been drawing downward sloping demand curves in this course, probably in your other courses, and it's a very basic premise in all of economics. We can, if we wanted to be imprecise, say that demand curves are either steep or they're flat. And what are we trying to do with the words steep or flat? What we're trying to do is describe how quantity changes when price changes in a market. We might say, for example, that if demand appears to be steep, that the price can change quite a bit and the quantity will not change that much. And again, that's a very imprecise statement. The problem with steep or flat is that they're tied to our idea of slope from mathematics. Does a line slope steeply, or does a line appear to be more flat? That's a valid statement in a given problem. However, the issue we face is that we need to consider a measure for sensitivity that will not vary because we switched from pounds to tons, or we switched from pecks to bushels, or we switched from metric tons to US tons. We need to have a measure and a way to describe the sensitivity of the quantity demanded to changes in price without relying upon how the underlying units are measured. Imagine if our goal is to find out how sensitive are American consumers to changes in the price of Coca-Cola versus how sensitive are consumers in China to changes in the price of Coca-Cola in China. We need to have a measure that can provide that comparison and not be confused by different currencies and not be confused by different units of measurement for the good in question. So we're looking for something that is like slope and that it is like being steep or flat, but we need something more precise. And economists have developed a more precise measurement, and that more precise measurement of the sensitivity of quantity demanded to changes in price is the price elasticity of demand. So how do we define the price elasticity of demand? Well, remember, elasticity measures sensitivity, or how much the quantity will stretch when price changes. And basically, there are two ways that are identical to describe in a definitional way the price elasticity of demand. The first way is to say that the price elasticity of demand is equal to the percentage change in quantity divided by the percentage change in price. Most texts in economics are using the Greek letter epsilon, which sort of looks like the number 3, as the symbol for the price elasticity of demand. What does it measure? Again, it's the sensitivity of changes in quantity demanded to changes in price. One measure of that is to simply write the definition of price elasticity of demand as the percentage change in quantity divided by the percentage change in price. An equivalent way, and somewhat simpler or harder depending upon your perspective, is in the lower left-hand corner of the slide. Here we have again a definitional form of the price elasticity of demand, and it looks simpler. It is the change in quantity divided by quantity, that whole entity divided by the change in price divided by price. Which form should you use? It doesn't really matter. They're both equivalent. It depends upon which one makes the most sense to you. So if we know that the elasticity measures sensitivity of changes in quantity to changes in price, what does it really mean? Well, first off, note that the elasticity number is going to be negative. Why will the elasticity number be negative? It will be negative because demand curves slope down. If price increases, quantity decreases. So the measure itself is going to be negative. And what economists do is they compare the numerical value of the estimate for the price elasticity of demand with -1. Now, what's special about -1? Well, if the price elasticity of demand is equal to -1, then the percentage change in price is equal to the percentage change in quantity. And that ratio of the quantity term to the price term will be equal to -1. That's a special case of elasticity, and it's referred to as a good having a unit elastic demand. Again, the -1 measure for elasticity is sort of a benchmark. It's a meaningful benchmark, as we'll see later, but it's a benchmark, and it means that the percentage change in quantity is equal to the percentage change in price. Now, what do economists mean if they feel that a good has a quantity demand that doesn't change that much with respect to price? Well, the imprecise way of saying that is to look at a demand curve that is pretty steep. And we show a steep demand curve in the bottom left-hand corner of the slide. In a more mathematical or a more precise way, what it means is that the percentage change in price is bigger than the percentage change in quantity. What that means is that price can change a lot and quantity won't change that much. Now, a lot and that much are relative terms. What exactly do we mean? Well, we mean that there's a bigger change in price than a bigger change in quantity. And that makes the elasticity measure, it's a ratio, remember, it's going to be between 0 and -1. So it's going to be something like -0.3 or -0.7. Those are inelastic demands. Now, what type of goods are going to have inelastic demands? And again, we trust that this is sort of a review for you. But basically, goods that have no substitutes are going to have an inelastic demand. If you find a good that consumers have to have, well, that good is likely to have an inelastic demand. Things like tobacco products have a very inelastic demand. Things that people need to have because of addiction generally have an inelastic demand. Another characteristic of these goods is we think that demand is more inelastic over a shorter period of time. So how many cans of Coca-Cola are going to be demanded tomorrow in Baltimore? That is probably an inelastic demand. If we were to say how many cans of Coca-Cola will be demanded in Baltimore over the next month, that's going to be less inelastic of a demand. So again, in review, an inelastic demand is when the percentage change in price can be bigger than the percentage change in quantity. In other words, the elasticity measure is between 0 and -1. We refer to that as an inelastic demand. The opposite case of an inelastic demand is an elastic demand. And if we have an elastic demand, we have a demand curve that, in imprecise terms, appears flat, meaning that a small change in price brings about a big change in quantity. Now, in more precise terms, what does that mean? Well, that means that the percentage change in price is less than the percentage change in quantity. that would give us an elasticity that is less than -1. So a number like -2 or -1.5 or -17. Those would all be elastic demands. The demand curve tends to appear in an imprecise way to be very flat. Now, what are some types of goods or characteristics of goods that might have an elastic demand? Well, a good that has a lot of substitutes, meaning consumers have choices for it, is likely to have an elastic demand. What types of goods are those? Well, let's consider the demand for automobiles in Baltimore. Probably the demand for automobiles in Baltimore is inelastic. If you live near Baltimore, you probably are going to have a car. You know, the price can change, but you're still going to need to have a car. Now let's consider a particular kind of car. If we look at the demand for Subaru Outbacks, that demand is going to be more elastic. Why would the Subaru Outlook demand be more elastic? It would be more elastic because there are substitutes for a Subaru Outback. There are substitutes for a Ford Focus. However, for cars as a whole, the demand is likely to be more inelastic. A second characteristic of the elasticity of demand is the time period involved. If we're looking over a longer time period for any good, consumers have the ability, given the longer time period, to substitute one good for another. So we think that goods with an elastic demand are associated with goods when they're measured over a long period of time. So we have now a numerical idea of what the elasticity measure means. We can identify the price elasticity of demand, what it means to be inelastic, and what it means to be elastic. And now it's time to turn our attention to actually calculating the price elasticity of demand. And as we go to calculate the price elasticity of demand, we will look at an arc calculation and a point calculation for the elasticity of demand. The first one we'll look at is the arc elasticities. Now, why is it called an arc elasticity? It's called an arc elasticity because we are looking at a change that takes place along a demand function or along the arc of a demand function. So if we see the picture there, we're thinking about a movement from point A to point B along a given demand function in response to a change in price, and we're calculating the elasticity over that arc or over that segment of the demand function. The arc elasticity calculation is sometimes useful and sometimes best because you need very little information. The only information you really need are 2 points on the demand function and an assumption that the demand function did not change. How are we going to calculate the arc elasticity of demand? Well, if we take the measure change in Q over change in P over P, we want to calculate, the change in Q over Q is going to be the percentage change in Q. How we're going to calculate that is we're going to look at the change in quantities across the two demand curve points and divide it by the average quantity across those two demand curve points. We'll do the same thing for price. Here's an example, and there will be more examples for you to work through on your own. Suppose I observe two transactions in a marketplace, and I don't believe that any demand shifting has taken place. So on a random Thursday, I observe a price is 133.15 and a quantity of 399 units. On the following day, on the Friday, I observe that the price is 135.44 and the quantity is 375. So there I have 2 points on a demand function. I have a price and quantity and a price and quantity. I need to calculate the percentage change in quantity, the percentage change in price, and then divide those results. So to find the change in quantity, what I'm going to need is I need the change in quantity and the average quantity. Well, the change in quantity is 375 minus 399. Does it matter if you use 399 minus 375 or 375 minus 399? It doesn't matter as long as you use the same order for price. The difference would be that if you screw up and miss your ordering of points, your elasticity number will be positive. So be careful to always change from one point to another. So the change in quantity here is 375 minus 399. The average quantity is 375 plus 399 divided by 2, or 387. So now I have the change in quantity and the average quantity. If I divide those two, I get the percentage change in quantity to be negative 0.0620. Am I done yet? Unfortunately not. We need now to calculate the percentage change in price. So continuing with the values we had for quantity and price, again we know that the percentage change in quantity is negative 0.06. We need to find the percentage change in price. Again we need the change in price and the average price. The percentage change in price is going to be 2.29 divided by 134.295, or 0.0171. I now know the percentage change in quantity and the percentage change in price. I can divide them and find that the arc elasticity of demand formula reveals that the elasticity is negative 3.678. So in this instance, demand is elastic.